Percent composition concentration by mass or by volume. So the by mass is the mass of the solute divided by the mass of the solution, and then we convert that to a percentage, of course, by multiplying by 100%. And then by volume, it would be the same idea, volume of the solution divided by the volume of the solution, and then once again we multiply by 100%. So this is a basic idea, and we could use any units for mass. Typically we use grams for mass, but it could be any unit, and volume we typically use milliliters, but once again it could be liters or other units as well. Now it's important to understand of a percent. So percent, think about the word cent is in that word. How many cents are in a dollar? Well, 100. So percent is the parts per 100. So think about it this way. If we have the whole thing is 100 of something, say we have a 5%, that means that 5% would be 5 out of 100, which is the whole thing. And then of course the rest of it here is 95. So in application to solutes or solvents or solutions, the whole thing would be 100 parts, either grams or milliliters, of the solution. And in that we would have 5 units, grams or milliliters, of the solute, and the 95 would be that of the solvent. So, for instance, this might be the salt, NaCl, that's dissolved in water. And the whole thing, salt plus water, makes the solution. What is the mass percent of NaCl in a solution made by dissolving 2 grams of NaCl in 56 grams of water? Think about this question carefully. We have the 2 grams of the solute. That would be like this part. We have the 56 grams of the water. That's this part. So it did not give us the amount of the solution. And for the formula, we need to divide mass of solute by mass of solution. So what do we need to do? Well, the mass of the solution is the mass of the solvent plus the mass of the solute, just like we saw here. Add together the solvent plus the solute, and that makes the whole. So the mass of the solute is 2.0 grams. The mass of the solvent is 56 grams. So in order to know the whole, or the mass of solution, we would need to add those two together, and so 58 grams is the mass of the solution. And so now we can just use the formula. The percent by mass is the mass of the solute over the mass of the solution times 100%. And so the mass of the solute then is 2.0 grams. The mass of the solution is 58.0 grams. And then we multiply by 100 to convert that to a percentage. And so that comes out to 3.45%. Let's try some applications of percent composition problems. Using percent composition, calculate the grams of KCl and the grams of water in 225 grams of an 8% by mass KCl solution. So this time we have the percentage and we have the mass of the solution, and we need to know, so it's the mass of the solution, we have the percentage, we want to know the grams of the solute and the grams of the solvent. So our unknowns here, we want the mass of the solute and we want the mass of the solvent. And we're given the percent by mass is 8%, and we're also given the mass of the solution. So that's going to be 225 grams. So if we visualize what's happening, we have 100 grams, we have an 8% solution, which means that in 100 grams of the solution, we have 8 grams of the solute. So we can pick an arbitrary unit to set up a conversion factor that relates the amount of the solute to the solution, 8 grams of solute per every 100 grams of solution. Now, within that, of course, the solvent we'll have to figure out as well, and that would be the amount of solution minus that of the solute makes the solvent, whatever's left. So let's figure out the amount of the solute. There are many ways to do this. Let's try using a conversion factor first. So we start with the amount of the solution. We have 225 grams of the solution. And we have this conversion factor. For every 100 grams of the solution, there are 8 grams of the solute. And now notice, what's 8 divided by 100? Well, 8 divided by 100 is 0.08. So isn't that the same as just changing the percent to a decimal and then multiplying it by the total amount of the solution? Isn't that what we do if you're in the store and it says 10% off? Wouldn't we change the percent to a decimal and we do 0.1 times the price? So it's the same idea. That's another way. If you understand a percentage, that's all we're doing. To find the amount, the relative amount of a whole, you multiply the percent as a decimal times the whole. And so that gives us 18 grams of the solute. Now another way you could solve this also is by plugging it back into the equation. So here we have the equation. So let's see what that would look like. If we plugged it back into the equation, something like this. So we know the percent by mass is the mass of the solute over the mass of the solution times 100%. So we know 8% then is the mass of the solute, which is the unknown. The mass of the solution, which was given to us, is 225 grams. And then you multiply by 100. This 100%, it's a unit that cancels out with this other unit. And it amounts to the same thing as doing, when you do the algebra, you have to divide both sides by 100. You'll end up with 0.08 times 225 equals x, which of course gives us the same thing, 18 grams of solute. So now that we know the grams of solute, that's half of our answer. The question also wanted to know the amount of the solvent. Well, since the solvent is the other portion that we add to the solute to make the solution, solute plus solvent makes solution. If we know solution and we know solute, we can subtract those to find the solvent. So the amount of the solution, so the mass of the solution minus the mass of the solutes makes the mass of the solvent. So the mass of the solution was 225 grams minus the mass of the solute, which we found 18 grams. So the mass of the solvent then is 207 grams, or the mass of water of the answer.